Hi everyone, we are going to be looking at solution to 4 questions. All 4 questions are from the topic triangles, reasonably easy questions, testing concepts of similarity of triangles and Pythagoras theorem. Appeared as part of the sample paper given by the CBSE Board for term 1 standard version of the paper. A girl walks 200 meters east, right? Let's say this is her starting point. She is walking 200 meters east, right? This is 200 meters east. And then 150 meters north is going upward. From this point, she is walking 150 meters north. So this is the place where she will be after covering this 200 meters and 150 meters. The distance of the girl from the starting point is what we need to find out, right? East, north will be at right angles to each other. So essentially, let's quickly construct a right triangle with 200 meters being one of the sides, starting point, midpoint, end point. So we'll have to find out the distance between where the girl right now is to the starting point, which is SE is what we need to measure. She is initially walking 200 meters towards east and then walking 150 meters towards north. So we have a 200, 150 and what right triangle? We'll have to find out the hypotenuse. So SE is equal to square root of 200 square plus 150 square. So that is what we need to find out. 200 square is equal to 40,000. 150 square, 15 square is 225. 150 square, add a couple of zeros, which will make it as 22,500. So what we have in terms of SC is equal to 62,500. We will write it as 625 into 100. So we can take square root quickly. 625, the square root is equal to 25. For 100, the square root is 10. So the measure of SC is equal to 250 meters. So distance between the girl where she is to the starting point is 250 meters. The lengths of the diagonals of a rhombus are 24 centimeters and 32 centimeters. This is an interesting question, right? It has 2-3 concepts embedded in it to solve the question. Then the length of the altitude of the rhombus is what the question is. ABCD is a rhombus. The diagonal lengths are given. Let's say AC is equal to 24 and BD is equal to 32. We'll have to find out the altitude of the rhombus. Altitude of the rhombus is the distance between two parallel sides. The perpendicular distance between any two parallel sides is going to give us the altitude, right? How are we going to go about it? We will be computing the area of the rhombus using two formulae. One formula to compute the area of the rhombus is equal to diagonal 1 into diagonal 2 divided by 2, which in our case is going to be equal to 24 into 32 divided by 2. You can think of it as 24 into 16. We will do this calculation later. We will not even compute what 24 into 16 right now is. So we found out area using the product of the diagonal formula. Next, the area of the diagonal, the area of the rhombus can also be found out as base into altitude. Let's take AD to be the base into the altitude, which is what the question is wanting us to find out. So do we know the value of AD? We do not know the value of AD. So let's set about finding out the value of AD. Well, look at it. We took AC to be equal to 24, BD to be equal to 32. The diagonals of a rhombus are unequal. They bisect each other and bisect each other at right angles. So these are all the properties of the diagonals of a rhombus. So diagonals will bisect each other and they are going to bisect at right angles. So if AC measures 24 units, AO, which is a point where BD intersects with AC, is going to be half of 24. So AO is equal to 12 centimeters. If BD is equal to 32, then OD will be equal to 16. So we have a right triangle AOD. In right triangle AOD, we'll have to compute the value of AD, which is one of the sides. In a rhombus, all 4 sides are equal. So AD is what we want to find out to compute the altitude. So AD will be equal to, applying Pythagoras theorem, AO is a 12, OD is a 16. So 12 square plus 16 square, square root of this is going to give us the answer. So AD is equal to square root of 144 plus 256, which is square root of 400, which is equal to 20. So we now know the side AD, which is equal to 20. We computed the area in the first formula, which is equal to 24 times 16. Just go back and check out. This is the area 24 times 16, which is equal to AD, which is 20, into the altitude. So which is what we need to find out. So the altitude is equal to 24 into 16 divided by 20. This will cancel out 5 times 4. This will cancel out 4 times 4. 24 into 4 is 96. 96 divided by 5 is equal to a 19.2. Right? Check out what the answer options are. 19.2. D is the answer. D is the altitude of this. 19.2 is the altitude of this rhombus. This is a question. The moment you see the symbol, we are talking about similar triangles. ABC and PQR are similar triangles, which means A and P are corresponding vertices, B and Q are corresponding vertices, C and R are corresponding vertices. Similarly, AB and PQ are corresponding sides, BC and QR are corresponding sides, and AC and PR are corresponding sides. So these are known to us. AM and PN, we'll check it out in the next slide, are altitudes to triangle ABC and PQR respectively, such that AB square is to PQ square is 4:9. What we need to compute is what is the ratio AM is to PN. A very easy question, right? So these are the corresponding sides AB, PQ, QR, BC, CA, RP, right? These are the corresponding sides. Now AB square is to PQ square is equal to 4:9, which means AB is to PQ is taking square root of 4 and 9, which will leave us with a 2:3. In any similar triangle, the ratio of the measures of corresponding lengths will be equal. AM is altitude to BC. Similarly, PN is altitude to QR, which means that because these two are the corresponding altitudes to corresponding sides BC and QR, their ratio will also be the same as the ratio of the lengths of the sides of the triangle. Lengths of the sides of the triangle are in the ratio of 2:3. Therefore, the altitudes AM is to PN will also be in the ratio 2:3. So that's the answer to this question. Very simple, straightforward question. Move on further. Again, we are talking about similar triangles. ABC is such that the three measures of sides are given, 3, 2, 2.5. We'll check it out in the next slide. ABC and DEF are similar, which means AD, BE, CF corresponding vertices, AB, DE, BC, EF, AC, DF are corresponding sides, right? One of the sides of the second triangle is given, which is equal to 4 centimeters. What we need to find out is the perimeter of triangle DEF. Again, a very simple question, right? So AB is equal to 3, BC is equal to 2, CA is equal to 2.5. Correspondingly, DEF is what we have, ABC, DEF, BC and EF, sorry, we'll look at it, right? ABC and DEF is what we have. BC and EF are the corresponding sides. What is the ratio of BC is to EF? Do we have that? Yes, BC is equal to 2, EF is equal to 4. So 2 and 4, the ratio is equal to 1:2. Essentially boils down to the fact that every side of DEF is going to be 2 times the measure of the corresponding side of ABC. So BC is 2, EF measured 4, CA is equal to 2.5, so FD will be equal to twice that, which is equal to 5. AB is equal to 3, D is a corresponding side which is going to be equal to 6. So the perimeter of DEF is the sum of these three sides. Perimeter of DEF is equal to 6 plus 4 plus 5, which is equal to 15 centimeters. Again, a very simple, straightforward question. The questions that tested in this set about similarity were all very straightforward, easy questions.
Before you leave, I want you to do 2 things. 1, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. And second thing, I want you to subscribe to this channel and turn on notifications so that you get notified every time a new video is uploaded. Spread the word about this channel to your friends and classmates.